What does a partial dependence plot (PDP) in scikit-learn sklearn visually depict? A. The correlation between two features. B. The distribution of target variable values. C. The relationship between a target variable and a specific feature, keeping other features constant. D. The importance of each feature in predicting the target variable. A. The correlation between two features. False. PDP focuses on the relationship between a single feature and the target variable, not the correlation between two features. Correlation measures the linear association between two variables. B. The distribution of target variable values. False. While PDPs can indirectly reveal information about the target variable's distribution, their primary purpose is to showcase the relationship between a feature and the predicted outcome. C. The relationship between a target variable and a specific feature, keeping other features constant. True. This is the fundamental definition of a PDP. It isolates the impact of a single feature on the prediction by averaging over all other features, thus revealing the marginal effect of the chosen feature. D. The importance of each feature in predicting the target variable. False. Feature importance is typically assessed using techniques like permutation importance or feature coefficients in linear models, PDPs. While providing insights into feature relationships, don't directly quantify feature importance. C. The relationship between a target variable and a specific feature, keeping other features constant. PDP explanation. A PDP is a graphical tool that helps visualize the relationship between a target variable and a particular feature, keeping other features constant. The plot shows how the predicted outcome changes as the chosen feature is varied across its range. Partial dependence plots (PDP). PDPs are used in machine learning to understand the relationship between a target variable and a specific feature. They are created by averaging the predicted values of the target variable over all possible combinations of values for the other features, keeping the chosen feature fixed. This helps to isolate the effect of the chosen feature on the target variable, allowing for better understanding of how the model works. Use cases. PDPs can be used to understand how features interact with each other to affect the target variable. For example, a PDP could show that the relationship between a feature and the target variable is different depending on the value of another feature. PDPs can be used to identify areas of the model's performance that could be improved. For example, a PDP could show that the model is not accurately predicting the target variable for certain values of a feature. PDPs can be used to identify nonlinear relationships between features and the target variable. This is important because many machine learning models are capable of capturing nonlinear relationships. Concept explanation. A PDP is a graphical tool that helps visualize the relationship between a target variable and a particular feature, keeping other features constant. The plot shows how the predicted outcome changes as the chosen feature is varied across its range. Implementation. sklearn. The code snippet shows how to create a PDP using the partial dependence and plot partial dependence functions in scikit-learn sklearn. The partial dependence function calculates the average predicted values of the target variable over all possible combinations of values for the other features, keeping the chosen feature fixed. The plot partial dependence function then plots the calculated partial dependence values against a chosen feature. Suppose we have a model that predicts house prices based on features like size, location, and number of bedrooms. We can use a PDP to understand the relationship between house size and price. while keeping location and number of bedrooms constant. The PDP will show how the predicted house price changes as the house size is varied, holding the other features fixed. This can reveal insights into the model's behavior, such as whether larger houses are always more expensive or if there is a nonlinear relationship between size and price. LTH3GT quiz question. LTH3GT LTBRGT LT font color black GT. You are using a random forest model for a classification task. You want to understand the importance of different features in predicting the target variable. How would you utilize permutation importance in sklearn to achieve this? LT font GT. LT font color black GTA. Use the permutation importance function from sklearn inspection to assess the importance of features. LT font GT. LT font color black GT permutation importance LTBRGT. This technique involves randomly shuffling the values of a specific feature in the dataset and observing the impact on the model's performance. If the model's performance significantly degrades after shuffling a feature, it indicates that the feature is important for prediction. LTBRGT LT font color black GT sklearn inspection. LTBRGT module within sklearn that provides tools for inspecting and understanding machine learning models, including permutation importance functionality. True. The permutation importance function in sklearn inspection is designed for directly calculating permutation importance, a method to assess feature significance. It is a direct and effective approach to determine feature relevance using permutation. LT font color black GTB. Analyze the feature importances attribute of the random forest model, e.g., model feature importances. LT font GT. LT font color black random forest LTBRGT. A popular ensemble learning algorithm that combines multiple decision trees to improve prediction accuracy and stability. LTBRGT LT font color black feature importance LTBRGT. A general concept in machine learning that refers to the relative contribution of each feature in predicting the target variable. Different methods can be employed to estimate feature importance. True. Random forest models inherently provide a feature importance attribute often called feature importances. This attribute captures the importance of features based on the Gini impurity reduction achieved by splitting on these features in the decision trees within the forest. This is a valuable tool for understanding feature relevance. LT font color black GTC. Use the mutual info classif function from sklearn features election to calculate feature importance. LT font GT. LT font color black GT sklearn features election. LTBRGT. A module in sklearn that offers methods for selecting relevant features for machine learning models. LTBRGT LT font color black mutual information. LTBRGT. A statistical measure that quantifies the dependency between two variables. In feature selection, mutual information can be used to assess the relationship between features and the target variable. True. Mutual information is a feature importance measure that quantifies the dependency between features and the target variable. The mutual info classif function in sklearn features election calculates this measure, providing insights into how features contribute to predicting the target class. LT font color black GTD. All of the above. LT font GT. The correct answer is D. All of the above. True. All the aforementioned methods are valid approaches for determining feature importance in a Context of a random forest model in sklearn. Each method provides valuable insights into feature relevance based on different perspectives. Permutation importance. Permutation importance is a feature importance technique that assesses the significance of features by shuffling their values and observing the impact on the model's performance. If shuffling a feature significantly degrades the model's performance, it implies that the feature is important for prediction. It is a model-agnostic technique, meaning it can be applied to any machine learning model. Feature importance. Feature importance is a central concept in machine learning, indicating the relative contribution of individual features to the prediction task. It is a powerful tool for understanding which features are most influential and can be used for model interpretation, feature selection, and model simplification. Sklearn, inspection. The sklearn, inspection module in sklearn offers tools for inspecting and understanding machine learning models. It provides functions like permutation importance, which is specifically designed for calculating permutation importance, and other visualization and analysis methods. Sklearn, features election. The sklearn, features election module in sklearn contains methods and techniques for selecting relevant features from datasets. It provides tools for dimensionality reduction, removing redundant or irrelevant features, and improving model performance by focusing on the most informative features. Mutual information. Mutual information is a statistical measure quantifying the dependency between two variables. It is used in feature selection to assess the relationship between features and the target variable. Higher mutual information indicates stronger dependence, suggesting that the feature provides useful information for predicting the target. Random forest. Random forest is a popular ensemble learning method that combines multiple decision trees to enhance prediction accuracy and stability. It is highly effective for various tasks like classification and regression. Random forest models inherently provide feature importance estimates based on the Gini impurity reduction achieved by splitting on those features in the individual decision trees. What is the primary use of partial dependence plots (PDP) in machine learning? To assess the individual influence of a specific feature on the model's predictions. To identify and eliminate highly correlated features from the dataset. To determine the optimal hyperparameters for a specific machine learning model. To understand the overall performance of the model across various data points. Correct. Partial dependence plots (PDPs) are visualization tools used to understand the relationship between a target variable and a specific feature in a machine learning model. They illustrate how changes in the chosen feature affect the model's predictions while holding other features constant. Explanation. Incorrect. While PDPs can reveal relationships between features, they are not primarily used for identifying and eliminating correlated features. Techniques like feature selection based on correlation analysis or other feature importance methods are more suitable for this purpose. Key concepts. Incorrect. PDPs are not directly used for hyperparameter optimization. Hyperparameter tuning is typically done using techniques like grid search (CV), which systematically explores a range of hyperparameter values to find the best configuration. Key concepts. Incorrect. Understanding the overall performance of a model is usually achieved through metrics like accuracy, precision, recall, or F1 score. PDPs focus on the individual influence of a specific feature, not the global model performance. Key concepts. A. Partial dependence refers to the average change in predictions as a specific feature varies while keeping other features constant. PDPs provide a visual representation of this relationship. In a loan risk prediction model, you can use PDPs to understand how the predicted credit risk changes as the loan amount increases, keeping other factors like income and credit score constant. Feature interaction explores how the influence of one feature changes based on the values of other features. PDPs can help identify such interactions. Consider a model predicting energy consumption. PDPs could reveal that the impact of temperature on energy consumption is different for different types of buildings, e.g., residential vs. commercial. This class in sklearn provides tools for generating PDPs. It allows you to easily visualize and interpret the influence of features on model predictions. You can utilize the partial dependence display class to generate PDPs for a random forest model and understand the individual impact of features like petal length and petal width on a classification of iris species. This function within the partial dependence display class allows you to plot PDPs, making it convenient to visualize the feature prediction relationship. You can use plot partial dependence to create PDPs for various features of your model and analyze how their values influence the predicted output. Grid search CV is a hyperparameter optimization technique that exhaustively searches a predefined grid of parameter values to find the optimal configuration for a given machine learning model. You can use grid search CV to optimize the hyperparameters of a support vector machine SVM model, such as the regularization parameter C and the kernel function. Feature importance is a measure of the relative contribution of each feature to the model's predictions. It helps rank features based on their influence. In a customer churn prediction model, feature importance can highlight features like customer tenure, recent usage, and satisfaction scores as being highly influential in determining churn likelihood. Mutual information is a statistical metric that quantifies the interdependence between two variables. It measures how much knowing the value of one variable reduces uncertainty about the other. You can use mutual information to understand the relationship between features like age and income. In a customer segmentation model, determining how much knowing one variable helps predict the other. Correlation measures the linear association between two variables. It can be positive, indicating that variables increase together, negative variables decrease together, or zero, no linear relationship. You can use correlation analysis to identify features like age and income that are highly correlated in a credit risk assessment model. This can help understand the impact of these features on risk predictions.